Hello everyone, welcome back to my channel. So in today's tutorial, I am going to discuss about the transfer characteristics of JFET. So transfer characteristics, it is the ID output current versus VGS input voltage curve keeping the VDS constant. For JFET, the ID is a function of VGS. It is defined by an equation that is called Shockley's equation. It is called um, ID equals IDSS multiplied 1 minus VGS divided by VP whole square. Here is a square term. So if it is R square law device or nonlinear device, the IDSS is drain to source shorted current. It is constant. The VP is pinch off voltage, that is also constant. The VGS is gate to source voltage, that is control variable. So in this Shockley's equation, the IDSS is constant and VP is also constant. So if we change the value of VGS, then only we can change the value of ID. After that, this is the JFET characteristics curve. From this characteristics curve, we can get the transfer characteristics curve. The JFET characteristics curve is the VDS versus ID curve, and the JFET transfer characteristics curve is the VGS versus ID curve. In the characteristics curve, we can see there are different values of ID for different values of VGS. So to get the transfer characteristics curve, at first we have to put the values of VGS in the x-axis. Then draw some vertical lines in the values of VGS. After that, we have to find for different values of VGS the value of ID. So for VGS equals 0 volt, the ID is about 8 milliampere. So just put a point for VGS equals to 0 volt in this axis. Next, for VGS equals minus 1 volt, ID is about 4.5 milliampere. So for VGS equals minus 1 volt, just put a point in the line. For VGS equals minus 2 volt, the value of ID is about 2 milliampere. So just put a point, and for VGS equals to minus 3 volt, the ID is about 0.5 milliampere. After giving all the point, then connect all the point and you will get the transfer characteristics curve. This is how you can get the transfer characteristics curve from the JFET characteristics curve. So here is a problem related to the transfer characteristics curve. Here it is, sketch the transfer defined by IDSS equals to 12 milliampere and VGS off equals to minus 6 volt. So VGS off is the VP, that is the pinch off voltage, and here is our Shockley's equation. So to draw the transfer characteristics curve, just give the ID in y-axis and put the values of VGS in the x-axis. So here the maximum value of ID is 12 milliampere. So you have to put points from 0 to 12. And the minimum value of VGS is minus 6 volt. So give the point from 0 to minus 6 volt in the x-axis. So for different values of VGS, just find out the value of ID. So we can input the values of VGS and find the value of ID. That is, for VGS equals to minus 1 volt, the value of ID will be about 8.33 milliampere. For VGS equals minus 2 volt, the ID will be about 5.33 milliampere. For VGS equals to minus 3 volt, the ID will be about 3 milliampere. For VGS equals to minus 4 volt, the ID will be about 1.33 milliampere. For VGS equals to minus 5 volt, the ID will be about 0.33 milliampere, and for VGS equals to minus 6 volt, the ID will be 0. So after we get all the points, then just connect all the points and you will get the transfer characteristics curve. After that, so here there is a term that is the VGS equals to -6, that is it is a negative value and it will be only for the internal JFET. Next, there is another problem, that is IDSS equals to 4 milliampere and here the VGS is 3 volt. So here VGS is positive, so it is the P channel JFET. We have our Shockley's equation. This will be same for these two values, that is IDSS 4 milliampere and VGS of 3 volt. We have to just put the values here and find out the points. And if we find out that for VGS equals to 1 volt, the ID will be about 1.78 milliampere. VGS equals to 2 volt, the ID will be about 0.44 milliampere. For VGS equals to 3 volt, the ID will be 0. And after getting all the points, just connect all the points and you will get the transfer characteristics curve for this JFET. So thank you so much for watching my video. If you like my video, then please press the like button and subscribe my channel. Thank you very much.